Welcome everyone, my name is Tóth Máté Péter and this is my colleague Katherine Cazco. We are working on the radio communication with the SZESAT-1 satellite. We are from the SZESAT Interdisciplinary College. But before we start, I would like to ask you a question. What do you think? What is the uninhabited island where your neighbor will be an astronaut? In the end, we will answer you. Why we bothered with this project? We started with the radio communication with the International Space Station, ISS, where we examined the technological background of the radio club we have in the dormitory and the methodological calculations for the possibility of the connection with the ISS. This way, we knew that the radio communication with the ISS will be possible. However, we have to back it up with our calculations, and this is where our job came through. After this work, we followed with the radio communication with the SZESAT-1 satellite, just to follow up our work. This way we can easier simulate and calculate with the things you have to calculate with if you want to make radio communication. One interesting fact that in May there will be an astronaut sent into space whose name is Kaputibor.
Then the small satellites. The Cube satellite will be using a non-directional antenna. Over the last researching, it is known for us the satellite takes 6 to 12 minutes to pass through our orbit. For the remaining time, the telemetry of the satellite cannot be received with our ground station. For that, the telemetry will be sent with LoRa, a long-range, lower power consumption technique. This way, other radio amateurs can also receive the telemetry data. Then, you can see the system design in the right part. The communication between the Pocket Cube and the Earth Station will be through the free space. For the communication, we will use a transceiver equipment with output power of 100 watts and with amplifier will be 1000 watts in FM. And also for receiving data will be used a RTL SDR software-defined radio. For uplink and downlink, it will be used a cross-jack antenna, and the data will be processed in the computer. Then the link budget. We verified that the connection will be possible when the satellite is above us at 412 kilometers and when it appears on the horizon at 4,500 kilometers. And for downlink, the connection is possible, but it will be necessary a special error correction system.
We had to go through lots of different calculations to make it even possible to calculate through the possibility of the radio communication itself. One simpler calculation is the free space attenuation. You have to take into consideration the distance between the satellite and the Earth itself, the humidity of the air, rains, clouds, and even birds and planes can alter your signal, so you have to also take these into consideration.
Then, the Earth Station aspects. In the top of the college, we have the radio equipment, the elevation azimuth dual control, the cross-jack antenna, the system for automate the movement of the rotor of the antenna, a cameras, and the computer for the necessary softwares.
We made connections through different satellites, but one we pointed out was with the SO50 satellite. With this satellite, we made a connection with a person who lives in Kapuvar. And you have to know that Kapuvar is roughly 60 kilometers away, but our signal went up in space for the satellite's receiver, and the satellite returned it from space into Earth through its transceiver. So our signal went minimum 400 kilometers to reach this destination, which I said before was roughly 60 kilometers. And for our answer, the island where your next neighbor will be an astronaut is the Falkland Island and Cargo Island. Of course, in the internet you can see lots of other answers also, which can be interesting. Köszönjük szépen a figyelmet!